So today we are going to demo our brand new DM1100DC deslagging machine for heavy plate. See here, we have some 5/8 material. We have more from the customer. So this machine has the deburring drum, which sits on oscillating rollers, so it can oscillate back and forth, but these rollers are also sitting on a hinge connected on each side with this torque bar, and which take pressure from these two air cylinders, and with that we can make a counterweight for the drum so that it can move up and down and follow the contour of the material. So you can run materials, plate, heavy plate, bigger parts with up to 1/4 inch of distortion lengthwise over the machine. And then it is followed up with two cross belts. We have the ceramic on here right now, brand new belts. Not for the best results for edge rounding, but at some point we will break those in two. For edge rounding, so that you have paintable parts afterwards. On the control here, of course this machine has a control. You can see that we can set the material thickness, set to 16.4, that's what we measured. We are going to run the conveyor belt, not quite at 3 meters per a minute, but we are going to run this at 1.2 so that we get good edge rounding. For the deburring we could go quicker for sure. And then we have the deburring drum on, we have the oscillation on, we have the cross belts on, we have all our height settings correct, and we go from there. So I'm going to close this door, and then we're just going to start the cycle. Of course, we have this machine ready for transport, sitting on a pallet, so it's not very convenient, and it's going to look a little awkward as we operate this. So at this point, we will just turn on the cycle here, and everything starts up. You can see that through here. The cross belts are coming on. It's measuring the length of the cross belt, so it sets the height correctly. And this machine, it compensates for the wear of the cross belt. And then as that comes on, the deburring drum starts turning, the cross belt starts turning, and when everything runs, that's when the conveyor belt starts going. These parts have very little draw, so we set the drum really light. We also need 500 RPM on the drum. Maximum RPM on the drum is 650. Also, as you see, we don't have dust collection right now on the machine, so we'll have quite a little bit of dust. Then the machine passes through the cross belt. The part passes through the cross belt, and that gives you the edge rounding. And we'll check afterwards if that is set well, or if you need to go a little bit lower, or what we want to do there. This, and we do need to set the cross belt a little bit lower. We still don't have a lot of edge rounding on this part. We will do that here on the reverse side, and you will see that it is very better. We will go here, we will go to 2 points. very nice soft contour that you will enjoy. And you can also see we are further into here, into the oxide than we were on the first side when we first did it. And actually, even if we wanted to, we could do this, we could give this a little bit more, but for most people this is actually fully satisfactory, very smooth, and this will already give you good paint quality. So now what we did is we tried that first piece for you and you saw what the results were. What you will be getting back looks completely different because we use that same piece to run it several times on each side through the machine to break in the paper a little bit because it would be too rough on the surface. When you have a brand new piece of 36 grit, it can be a little bit rough on the first few pieces. But if you just run for the first 10-15 minutes or so, then you already, that paper will break in nicely. Overall, a 36 grit on a machine like this with parts like this which have very little dross and can be used very lightly should last you between 15 and 20 operating hours. So now what I will show you is basically, of course, you can take these parts and you can run multiple of them on the thing. And I'm still using the middle track. Normally you would fill with this part, this side, you would fill the entire table. And the reason why I'm doing this is because this is where we broke the paper in. So you can hear from the sound already that it's a little gentler, a little softer, not as aggressive. Of course, running a single piece is a little bit of an active case because you have to wait for it to come out. Normally you would run pieces continuously. Now you will see something here that is typically for this machine. You see how we are removing material from the edge and we are rounding that edge. This is exactly where we want to remove if we have a lot of dross, but we are just polishing the surface. You see this here. We could set this drum a little bit lower, still to get a little bit more of that silver ring, and we will do so now that the paper is broken in. But this is the surface that you should expect of a machine like this. Not removing material from the surface, just from the edge. And that is why that paper will last you a long time and you can remove a lot of dross. So here we have your 13.7 millimeter material. So what we did is you have to restart the machine. We set it to the new material thickness, and we also brought the drum down a little bit harder now that the paper starts to breaking in, so that we have a little bit more pressure, maybe show you a little bit more edge. Okay, and we have the bird side here and on this part here. Off this video we will also run the reverse sides of those parts, but the video would get awful long if you do that all. We have this magnetic strip in the middle, so for small parts like this you want to put them on the magnet so that they hold under the drum. Then under the cross belt will actually push the part down, and it will not require a magnet underneath there. processing at 4 feet a minute. If you wanted more edge rounding, you would go slower. If you had more slag or things like that, you would go slower. Here we have something interesting. This was a flat piece of slag on the top. The machine has a tough time remove that because you don't really remove any slag from the top. So, but we remove everything on the edges because that's where we press. If you have things like this, you do need to remove that basically simply by hammering it off like this before you do it. Okay? So, this is the result here, and again you have a nice and rounded edge other than that, which is already painted. So now we have the 3/4 inch material. There we have a little bit of slag on the edges, right? And so forth. So what I will do here is I will actually even go a little bit slower. I'll just bring that down to 1, which is about 40 inches a minute. Okay? Here we were grinding a little bit harder because now we're having some slag, and you will see that also on the width of that ring around the outside edge. Heavier part would have more slag, but even there, very little on the surface, but you can see where it really removes material from the rim. So this was the example of how you can do this a little bit the harder way. On the other side, I have your other piece of 3/4, and we're going to run that right away. Even though this has almost no draft again, you see that I always run at an angle. This is for the cross belt, but also for the drum. The drum works best when it goes over it, not perfectly parallel to an edge, but always slightly. Here now we have your 25.4. That's also an easy part. It has a little bit of slag on it. So for this, I'm going to increase the speed again to 4 feet per minute, 1.2 meters, so that it goes a little bit quicker. And of course, this is the part that definitely has to go on the max. very nice, great edge quality, and so forth. Just so that you have an idea of how many parts you could be running of this on a machine. So you have a magnet which is like this. One, two, you can go a little bit outside of the magnet, 3 parts, and you have about a 6-inch part. So at 4 feet a minute, you would, at 4 feet per minute, you would be running approximately 8 times 3, 24 parts per minute. Which, if you multiply that by 60, you would come out to over 1,300 parts per hour per single side. Just to give you an idea of what the productivity of a machine like this is. In reality, in practicality, you wouldn't run 1,300 parts. You probably would run 70 or 80% of that. 900 to 1,000 parts, but that still would be an incredible amount of parts. So, now, it gets a little bit more complicated. Here you have a part which is taller than it is wide. Normally we say you want to be 1.5 times as wide as you are tall. The magnet will hold this down, but because you have such high torque forces, you are really at risk, especially if somebody puts it a little bit in too sideways, that the part would roll over and you would put a dent in your drum. You don't want that. This is why we made, for this part, we have made a template. So in order to run this, of course, you need to set the machine. So if you want to do that, you would want to make yourself multiple templates of that. So for this, we need to run this machine. So this is 45 millimeters tall, which is easily in the opening of that machine. So you have to go here to 45. There you see it idling up. We're going to overshoot a little bit. Fine. There we are. So, of course, this is not a production template, this is just to make one piece. And then the magnet can still suck it down, but it can't really flip. You see that I'm running it over the longest feature of the part, so that when the drum interacts with it, it's less likely that It'd be interesting to see what this does in the crossbelt, because we don't have a magnet in the crossbelt. So you have a little bit of draft here on the side. This, of course, the machine cannot treat. Whatever you have, you need to adjust your cut. What you want to have a cut where all your spikes are standing up straight, so that you can that you have less of this serration on the side. But from the top, and again, maintainability, that part is completely deburred and clean. Right? And we have a second one which we will run out, but again we will leave that out of the video because that gives us a little bit more time than afterwards to, or otherwise the video would be too long, obviously. Now we have these. These are 34.5 millimeter tall, and they are 76 millimeter long and 64 millimeter wide. So this will work with the magnet. This will hold by itself. But of course we need to set the thickness to the correct 34.5. And again, I run over the longest feature of the part, diagonal. In general, you really need to be careful that you don't put in those parts sideways. That sounded astonishingly hard. So, the reason why that was a good demo is because I made a mistake, okay? These parts are not 34.5, they are 38.5. So we are 4 millimeters too low. And this is why I just said before, this sounds astonishingly hard. And you can see how hard we ground that part. And also with the edge rounding, you saw a lot of dust coming off the cross belt. So you won't break anything in the machine, but in general, this is of course not a very good idea. So this is a result of somebody that set the machine up wrong, in my case, 4 millimeters too low. So I should have checked before I put that in what it is. Now we also have some temperature in this part. It was actually 38.5. Keep it next to it. Then you will see that. That sounded a lot better. Ultimately, your operators will learn to run this machine by ear as much as by eye and by results, of course. noticeable difference. This is the correct setting, obviously. Coming to a critical topic. So here you want to run aluminum. Obviously this is a dry machine. You need to separate aluminum from steel. You cannot run that in a mixed on a machine like this because you're going to make a lot of aluminum dust. And even if you collect it in a wet dust collector, you would have to completely clean out the machine after you run aluminum. So if you want to avoid that risk, the strict rule needs to be that you do not, on a machine like this, do not want to mix aluminum with steel. But for the purpose of the demo of what this will do, we're going to run this for you here right now. I'm going to lighten up the drum a little bit because it is aluminum. Because we don't need as much pressure on it. And then we go from there. Okay. And by the way, we're going to run this at 8 feet per minute. Obviously, aluminum isn't even a challenge relative to steel. To run aluminum after steel is not a problem, but to run steel after aluminum is a huge problem. Super nice edge, totally. Again, if you have small parts like this, you do need to have a template because they would tip. I mean, this is just too small for a slagging machine like this. And if you have big burrs like this could even collide with the safety flap in the beginning. Second half, back side of the coming out. Now we're going to take this